So we can start, right? Okay, thank you. Good, I won't say good evening, but it's not the evening, so nice to meet you here. We are from the Open Telekom Cloud, and now in this slot, we want to present or give you some overview what we are doing in the direction of AI, of course, and of course, how our Open Telekom Cloud looks like, what is behind this, and so on. Let's start. Well, first of all, I think we have to present ourselves. Please start.
Hello, everyone. My name is Ferenc Kukucska. I've been working in the BigData and AI spot for 4.5 years now as an architect and have been in the AI industry since 2017. So in these past 7 years, I've worked on many interesting AI projects, smart camera systems, chatbot, intelligent search engines. But in the last couple of years, I'm focusing much more on DevOps projects built with technologies like Kubernetes, Argo CD, Helm, Terraform. And you will see each of these as a building block in our presentation today.
Wow, amazing. Okay, for me, it is not that long. I'm a senior product manager for the Open Telekom Cloud. I'm responsible for 16 services. We offer to all of our customers 56. And based on these 16 services, it is database, big data, and AI. I'm more responsible for the marketing side, so taking care about our services, that they have all features set, and so on. I am working from Open Telekom Cloud since 3 years. For the ones that they don't know where this Open Telekom Cloud was created, because we get in our booth a lot of questions like, I never hear about you. I just saw this T-Mobile, we can buy a mobile device and so on. Open Telekom Cloud was just created, or first day it was on 2016, and since 2016 we are there.
So our demo will contain 4 major parts. First, me and Hector will give you a basic overview about Open Telekom Cloud, and we will focus on its AI service model arts, advantages of model arts, and its AI portfolio. Then comes the demo segment with the second part, where Hector will present you the LLM chatbot solution of ours, and also the web application, and I will be the one who will talk you about its technical stack only in general terms. Then comes the people counter application, where I will demo you both the web app and the mobile app as well. And finally, the landslide predictor, where I will focus on its environmental importance and its web application. So let's dive into the world of Open Telekom Cloud with Hector.
Yes, great, amazing. So as I told you before, it's called Open Telekom Cloud. Telecom itself, it has many clouds, but the most successful cloud that Telecom is offering right now, it's Open Telekom Cloud. There are many reasons why Open Telekom Cloud is recently, I mean the last 5 years, very in. One of them is the data centers are in Germany. That is the most important part. So with that, we are doing this supporting of GDPR. And with this GDPR, that's most regulations that most of the companies in Europe has to just fulfill in this part. The second part of it is we have many certifications that are just achieved, that our cloud is a public cloud. Many of our customers, we have for any kind of customer this offering. So that means even for small size companies like lawyers, agencies, to the middle companies, insurance, banks, also scientific institutions and healthcare, they are all part of our customers. That means we are really a huge cloud. With these 56 services that I told you, we have included there not only just development of VMs, we have also database in any kind, so SQL, NoSQL, data warehousing, AI, analytics, and some of APIs that we can offer to our customers. In short, the data are processed in Germany, so that means the data will not just leave the country. We are in the way of sovereign cloud, that the data that we offer, it's data that you can just access and nobody else will then access them. And of course, last but not least, it's as you hear in the last 2 years, all governance from all countries in Europe, they want to just reduce the CO2. We are CO2 zero. That means we are taking the most energy to our data centers from wind energy. In short, then we have 2 data centers. These data centers, they are located in Germany, as you may see. The other ones, it is one related here in Netherlands. So we have 2 data centers also in Netherlands. This is a second region that we call. And for the ones that also visit us today and recently, they are asking also for private cloud. So that means in this case, like we offer in Switzerland, we have a private cloud there that is more confirmed and compliant with the regulations there in the Netherlands. To give you a briefly overview of what is really this Open Telecom Cloud, because probably they will say, oh, this Open Telecom Cloud is just running in a cellar or a brewery in Germany, and that's it. No, this is not like this. Indeed, we have a lot of virtual CPUs, RAM storage that can be used. Some of our customers, for example, that we have is CERN Institute from Switzerland. The scientists, they need a lot of CPUs, and they are accessing thousands of CPUs in our contract only just to get that delivery. On the other side, it's not just CPUs, also GPUs, because nowadays it's without GPUs, no AI at all, and that is the way that we are also delivering this kind of solution there. Last but not least, only just to make a brief summary of this for this Open Telecom Cloud, then we want to show you that we are GDPR compliant. This is the one part, so that means with data privacy, we are, of course, fulfilled. The sovereignty, your data is your data. Nobody takes care of your, only you, of this data. Security is always what customers start asking. Security in the way of encryption and the way how we meet the regulations that the data will be really skipped in the data centers. It's also based on the regulation that we have, so legal part is also there. And the reliability, it means we support this zero outage. That means our data centers are running 24/7. So with that means it's not such kind of happenings in the recently that data centers just get down and customers still be claimed because the application didn't work and they lost some of them the business. So that means we're really focused that we deliver zero outage really in our data centers.
On this slide, you can see almost all the services of Open Telecom Cloud and their corresponding services with the 3 big cloud providers, Azure, GCP or Google Cloud Platform, and the AWS Amazon Web Services. As you can see, OTC has all the main and relevant services, just like the 3 big cloud providers. I am not going to iterate through each of the services, only highlight those that me and Hector will mention during our presentation. So in the first row, you can see the VM solutions, the most widespread cloud components, the ECS, in OTC, they are called Elastic Cloud Servers, but basically they are EC2 in AWS, Elastic Compute Clouds, and Compute Engine in GCP. Let's turn from the VM solutions to the microservice or container-based solutions. In OTC, they are called Cloud Container Engine, so it's similar to GKE, Google Kubernetes Engine, and Elastic Container Service in AWS. This is the service that we used when deploying every 3 application that we will present today. SWR is the software repository for containers that we pushed or container images to. OBS is for storing every type of files, like music files, video files, text documents, large compressed files. So this is where we store our data sets. And finally, I will point out our AI service, ModelArts, next to AWS SageMaker, GCP's AutoML, and Azure's Machine Learning, because we will dive into ModelArts more deeply in the upcoming slides. So let's see ModelArts. What's cool about ModelArts is that you don't really have to be expert data scientist with long years of coding experience after thousands of AI projects behind you, because there is a tool called XML where you don't need to code, just import your data set, upload your annotation file, click on train, and in a few minutes or hours, depending on the size of your data set, you can already see how your model performs. There you can see the zero coding, zero AI experience. But if you have some coding experience, there are pre-configured hyperparameters and built-in algorithms provided for you, like ResNet50, faster RCNN, VGG16, SegNet VGG. So it's halfway between beginner and expert AI developer. It's a good opportunity when you just want to experiment and build a model quickly. There you can see below ultrafast the training ResNet50 parameters. And the third option suits you the best if you are a professional data scientist. There are a lot of AI frameworks that you can select from, like TensorFlow, PyTorch, XGBoost, scikit-learn, Caffe, and Mixnet. But aside from the custom AI frameworks, custom container is also an option where you are the freest. So this is the most customizable one. By this one, you have the most freedom because you can set the boot commands, training parameters, which processing methods to use. So a lot of options are available for you.
That in the beginning from Model Arts, only just to make also a short review. We use on Model Arts open source frameworks. As you may see, you know most of them because TensorFlow is recently very in everywhere. So we offer these open source frameworks for free. So that means they are there. We also offer the GPUs that you will need also to use for your trainings. And of course, it is Model Arts is just an AI service. But as usual, when we talk always about AI service, it's not like an AI service will solve all our lives. So in this case, AI service is just part of the tool chain only used to achieve a business solution. In this case, before Model Arts or after Model Arts, you can also interact with other existing services that we have on the Open Telekom Cloud. In this case, like data ingestion service that we have there, data warehousing, MapReduce service, cloud search service. So it means we have exactly the full service that can work together with Model Arts, and at the end you will get your final solution. In this sense, Model Arts, it's only just a part between of it. They have solution, but have to take in consideration, it's not just Model Arts what we are talking about, it is more Model Arts and the other services there.
So currently, our auto-learning service XML has 3 services: image classification, object detection, and predictive analytics. As for image classification, you can see our COVID detector tool there. The development of COVID detector tool was really easy, so we just uploaded the data set, the COVID, pneumonia, and healthy folders to OBS, Object Storage Service, and with the corresponding X-ray images, so the 3 categories. Then we went into XML, we imported that OBS path of the COVID dataset, clicked on train, and that easy. So aside from the COVID detector tool, we also used plant disease for image classification and landslide predictor that I will demo in a couple of minutes. As for object detection, it can identify many types of objects, as you can see, cars, people, magenta T signs, so a lot of options are available for you. You just have to upload the dataset and also the annotation file that contains the parameters of the bounding boxes and click on train, that easy. And finally, the predictive analytics, so this is the easiest one of all because you just have to upload a CSV file with the feature columns and the target column. Select the target column as the one to be predicted and click on train. So this is what we used for the air quality index predictor last year.
So now let's move with some examples because only just theory it's one half of the story. But what about the real life? Let's say like that. We have prepared 3 use cases. I'm happy that I have the chance to present the first one. In this one, it is the deployment of a large language model. So we have Llama 3 behind that. It could be also Mistral. So it is not just that it has to be like this. It's just one example, what it can be deployed on the OTC. This solution will be deployed in Kubernetes, so in a Kubernetes container. And we also support this RIG. That is also a part of the solution. The main or the goal of this presentation is that we can show some of our customers are asking, because we're in Germany, they are saying, okay, there are a lot of large language models, they support only English, what about German? Or they all say from other countries, what about Spanish? What about French? What about too many other languages? And as we all know, these large language models are not too easy to get that working, but it doesn't mean that we need one specific model for every language, because this is not the full truth. Actually, the value of these large language models is when you have one that is working. Would you need one that is really working? The accuracy is very good. The quality is also excellent. So what we do in this example is we just, before we send the prompt message to the large language model, we just do the translation to English, and then just get the input to the large language model that is just has the power to gen AI in English. After the answer is there, we translate back to the original language, and this is it. So as you may see, it's a very easy solution. I just told you in all the steps what it could be do. Here is the full process that we are using. So that means this is the full chain that we are using. You have an input, you have prompt, you do this the speech to text, because it can also use speech to text in this recognition. Then translate. After translation, go to the model. The model, if there is RIG there, then it will be use the RIG also to get the target output desired in this case. And after all, just revert it back to the other one.
So let's have a look at the technology stack of our chatbot solution. So we use the state-of-the-art Llama 3 as our base model. We did the prototyping on a separate ECS VM, Elastic Cloud Server. Once we produced a proper image, we uploaded it to SWR, Software Repository for Containers, and then we went into model arts and training management, and we created a training job. So we selected the custom image as the boot mode, and after that, I selected the highest available GPUs, so I modified on the GPU spec, and 8 NVIDIA V100. Once we were done with the image, of course, we selected the boot command, Python, training.py, and this stuff. But basically, that's it. We clicked on train, and once we were done with that, we could find our trained model in the AI application section of Model Arts, and then we could deploy it as a real-time service. So we got an endpoint URL, prediction URL, which we could integrate into the website that Hector will demo in a next slide. So we did the deployment, containerized the application, created a Kubernetes cluster in a Cloud Container Engine, CC. We used the Argo CD as the GitOps CD tool, and we used the Helm as the templating engine. In the last line, you can see what libraries we used from the Llama framework.
So then let's start with the use case. So at this moment, you may see there's the end application that is running there. So we have configured a web application. In this web application, the input that we have there, it's still there. As you may see, you have in this demo the option also to configure RIG. So just to input your documents that are necessary for this. In this case, this is the standard question there. As you may see, it is written in English. Let's start with an English question. In this case, what is this? Model arts that we're using, then the output is thrown up. It's there, but now let's change the language. We're still using the same prompt. I mean, with a different question. We are now asking in German about map produce service. So we'll send it the prompt there. The answer is then after the model is being translated into German, and then you may see it is working very nice. The last question is just in Spanish. So we start asking there how I can install a Helm application there. Send it again to the same model. So we don't have one model for one language. We just have one model for all language. And then the input, as you may see, it's very clear. I already verified the outputs because I'm working from Germany and I'm from Mexico. So there's only just one simple word that is wrong. The most of the answer in this prompt are really well answered. So that means in our case, this use case is very powerful. On the other hand, you can also use as an input the microphone, so you can interact with the model and the model can answer you. So it is also a straightforward solution.
So let's have a look at the second project, People Counter. So people counting is exactly what the naming suggests, trying to precisely match a number of people on the pictures, video streams, so usually large areas, undergrounds, cities, concerts. Our solution offers a reliable way to count people and provide insightful factors based on those results. So we used the Shanghai Tech dataset for the model training, and we created a web application and a mobile application as well. Let's see the Shanghai Tech dataset. So it's a large-scale crowd counting dataset. It consists of nearly 1,200 annotated crowd images. As you can see, there are many use cases of this application. So, for example, traffic companies can get valuable results based on the number of passengers. So on train and tram stations, the signboard can tell people where to get on. But aside from the traffic, it can be useful in concerts, in conferences, in large festivals like Oktoberfest in Germany, and other public and private events. So let's have a look at the technology stack. We aim to utilize 100% native OTC services for every 3 applications, so for this people counter as well. We did everything in model art, so the data preparation, the model building, the training management, and the real-time service deployment. Once we were given a proper API endpoint URL, we created a web application for that, and I will demo it on the next slide. And we use Docker, Kubernetes, and Helm. So here you can see the peoplecounter.otcservice.com. So concerts, festivals, where you can use it, the banner, the slogans of our people counter application. Here is the prediction box. So I selected 2 images for that. Both of them were from the Shanghai dataset. One is containing a large crowd. As you can see, it contains 305 people. Our training was quite accurate, 86% of accuracy. And let me present you the second picture. It contains a smaller crowd. It contains around 150 people. So I will zoom in, as you can see, and just drag and drop it into the predictor box. And basically, that's it. I don't have to click on upload, and as you can see there, our people counter predictor did the inference in a couple of seconds. So that was the web application, and we developed also mobile application as well. So I came from a small town in Hungary. There is you can't really find big crowds there, but I was there in the Saints Day, where I took a photo, tested the application. Here you can see us, the developers of the people counter application. So I just picked out my mobile phone from my pocket, clicked on camera, and there you can see the crowd of the Saints Day. As I counted, approximately there were 80, 90 people. Clicked on OK, waited a few seconds for the upload, and there you can see the predicted number is 80. So that's about it for the people counter application. And our last project is the landslide detector application. So you might remember from previous years, each year we are trying to demonstrate something environment-related AI project to demonstrate the nature consciousness of our company and the green OTC, so plant disease detector, air quality index predictor, and these kinds of stuff. So we use this landslide detector application, and you can have the questions, what are these landslides? So landslides are widespread occurrences that can become catastrophic when they occur near towns, settlements, villages, infrastructure. So the detection, the prediction, and the monitoring of landslides have become fundamental by nowadays. Just have a look at the current environmental crisis, Storm Boris, and the Danube River floods. So landslides have been reported, and additional incidents are possible, especially in hilly or mountainous areas where heavy rain saturates the soil. So let's see on the next slide how we utilize AI to fight landslide risks. So here you can see the BigData dataset. BigData is Chinese city where a lot of landslides are happening. So it contains approximately 2,100 annotated images, landslides and non-landslides. So we did some data augmentation on this dataset because the number of landslide images were 3 times less than the number of non-landslide images. So we use some Keras techniques, skewing, horizontally flipping, rotating the original images. So we produced more landslide images. We uploaded it to OTC's object storage service, OBS. Then we went into XML. Basically, we were importing the OBS path, and that's it. Clicked on train. And here you can see the web application for that. So again, landslide predictor application, make our life greener, predict based on satellite images. So we are trying to, predict on the satellite images. Here you can see some examples from the BigData landslide dataset. I selected this non-landslide image. So this is the validation data of the BigData dataset. As you can see, the frame is green, and I also colored the text green. So these were 2 images from the data validation, and let me present you also some landslide dataset. So as you can see, these are satellite images of Earth from space. And here you can see one landslide images. And you can have the question based on what are we predicting. So the type of the landslide, the risk posed by the landslide, the deformation patterns, the size of the affected area, so based on these. So with this application, we are trying to demonstrate to our customers how the different DevOps technologies and cloud technologies can work together with artificial intelligence in a real-life example. And unfortunately, these landslides are happening more and more frequently, but with a high-quality model and the satisfactory accuracy, we can maybe obtain early warnings of results and put in place the necessary preventive measures.
Amazing. So I think We are now done with our presentation. Thank you so much to be here. Now are the slot when we just don't we stop presenting, and then if there is someone that has some question, please go ahead. Yes, please. Yes.
Are you doing any training in languages other than English, or are you training in English and just using translation for the chat experience?
The model that we have behind that on this large language model is actually a Llama 3.
Okay, so that's there. Okay.
Yes, yes, you're welcome. Anything else? Yes, please.
Technical question. In the inner mechanics of your code, have you used any libraries like LangChain, Llama Index, that goes beyond PyTorch and classical training stuff?
Have you got it?
No, no.
You have to be. Let's go a little bit closer to here. We couldn't listen correctly. Sorry for that. Oh, you have a microphone there. Thank you so much.
So I heard you. So I seen your tech stack. In a high level, I see you focused on the deployment stuff, Kubernetes or Llama. But in your code, have you gone through any specific LLM-oriented frameworks like LangChain or Llama Index or that stuff? I mean, I'm curious to learn how the industry is using these new frameworks, if you use them.
We took this state-of-the-art Llama 3, and based on that, we trained this on the documentation of the Open Telekom Cloud. So we used a couple of Llama frameworks, as you could see, and basically, once we were done with that, we uploaded it and did the deployment and the training in Model Arts. So basically, that was it regarding. No. Yes.
Okay. Mm-hmm. Vector database for RAG.
Mm. No.
No, we're not using on RAG, right?
No, no.
No, we're not using it.
Yes?
Regarding the chat again, does it also understand speech?
Yes.
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 Because I saw you had whisper as the model.
Yes, like a whisper. Yes, you just ask the question. It always depends on the model. If you are using a really strong model with high quality, then the answer that you expect in the language, it will be very good. Of course, in this example, for example, we are using 3 different languages, so that means it's more focused on English. For the answer in Spanish or German, we need exactly a specific voice for that specific language, because if we get the answer in German, it will be speak in a not very good quality for German language.
Speech to text.
Yes.
Does that also work? Because in my experience, for instance, it doesn't work.
Speech to text in English, it is working well. Speech to text in German or in Spanish, no. Yes. Any other questions?
Can you please explain a little bit more about the chat and how basically you've trained it to act like you want? Is there fine tuning as well?
Yes, yes, fine. Yes, we fine-tuned, yes, the model.
There's no RAG around it. It's just where is it pulling its data? That's what I'm asking.
So, for example, Hector showed you that we can configure reg. So once you click on that, basically what you can do is upload a text document, some kind of Word documents, and it lands in OBS, Object Storage Service from OBS, and continuously, this whole model is pulling the folder from OBS, so it's integrated these two stuff. And once it has it, then basically, for example, you could see there that we asked the question like model arts. Before that, I uploaded the documentation, the full documentation of model arts. And after that, before that, it doesn't really know anything about model arts. But once I, upload the documents about model arts, it can answer a lot of questions because of the Llama framework.
Okay, so you're using the Llama framework, but does that do like a RAG-like behavior where it pulls the relevant information from the documents to this specific
Yes.
question, and then the LLM gets all of it together?
Yes, yes.
Yes, this is it.
But you're not using any vector databases to
No.
At this point, no.
embed this?
No, at this point, no. But it is also possible. I mean, we also offer vector database on the Open Telecom Cloud, but in this case, no.
Yeah, I'm finished. Sorry.
Thanks.
Thank you.
Okay, thank you so much.
Thank you.